Good evening, everyone. Welcome to the February 2022 virtual monthly meeting of the Minnesota Astronomical Society. I am your president, and I'll be the host of this meeting tonight. Here's the crew. Here's the crew of the executive board. I haven't had time to check to see who's on tonight. Trina might not be on. She was feeling ill earlier today, but Matt's on, our treasurer. Yep. John,
I see it.
Gunnar, Conrad. I hope you guys are all on.
Trina's on.
Trina's on. Yay, Trina.
Trying to catch up here. Nope. Okay.
Well, you're even a little weak, I can tell.
We had a good time at the movie last night.
Yeah, so
I'm on.
So yeah, that just for everybody that's on tonight, we had the opportunity. Some people from the MAS had an opportunity to go see a preview viewing of Moonfall. I understand it was entertaining. That's might be as far as I go with that. So welcome everybody. Welcome especially to new members to the society. I always like to display those. So welcome. There's lots of opportunities to volunteer and take advantage of all the wonderful things this society has to offer. So one more boring topic before we move on. Dave Faulkner, I need you for about 3 minutes, if you don't mind, to talk about the Constitution and bylaws that we're going to talk about next month.
Okay. I'll go into a little more detail when I make a presentation next month, but the Constitution has been completed and sent to the attorney for her review. I haven't heard back from her yet, but we will work with her to make sure that the Constitution is in the up and up, and the board will review it, and we will present that. And I'm going to present a presentation that summarizes the key points of the Constitution when we do that. And to be clear, it's going to be known as the Articles of Incorporation and Bylaws. That's what it really is. I want to thank everyone, and I will thank the individuals in the presentation who worked on this Constitution, this Articles of Incorporation and Bylaws. There was a lot of work that several people did participate in to update our Constitution from where it is today to something that is current. It's been like 40 years since the original Constitution was put together. There's been a lot of changes to law and statutes that we had to really address in the Articles of Incorporation and Bylaws. So I'm expecting this back from the lawyer in time for us to be able to present this in March, but I don't know how much back and forth we're going to have. We may have a little bit of back and forth. So the target is to present this at the March meeting, but we'll keep you informed as to the progress toward that.
Thank you, Dave. And yep. And I mean, we're going to establish a link. We're doing all those things. We're going to make sure that the Constitution is reviewed by those that want to review it. And there's going to be a formal vote that we're going to do just as similar to what we do when we do our elections. So you got to be a member, in good standing, blah, blah, blah. We have to make sure that we reach at least 20% of our membership. So all right, moving along. Well, a blank one. Thank you, volunteers, again. Executive board, I mean, we had 2 meetings, we had a bunch of chit chat back and forth, lots of things talking about the budget this last month. So from me, thank you very much. You made my job easier. Thank you for volunteers for the January BSIG. I was actually on that. There was quite a few people on that. I thought that was well presented and very good. Continued work on the MAS website update. That's pretty much being headed up by Vaults. And thank you, Steve Emmerich. Steve Emmerich, you did a lot of work that I didn't even ask for.
I thought you were going to strangle me instead of thank me.
Nope. It's all about love. You did, you provided valuable information for the board, for me to give good, accurate information to support the reasons why we needed to raise the dues, and we needed history, and you provided that, and you provided some other things that I chose not to use, but it wasn't on purpose. It was actually accidental. So, but thank you very much, Steve. All right, moving along. Next meeting. Hey, we're going to try this again. We're going to try to have a face-to-face meeting in March, March 3rd. And just for everybody that's concerned about attending a meeting face-to-face, it's going to be on Zoom again. You can attend that way, or you can just wait and we'll record it and we'll post it up on YouTube. Thank you, Doug Neverman, for this picture. It didn't get deleted, but there it is. Nice picture of M31. Just a reminder, Slack is still out there. Haven't seen much growth over the last few months, but it's definitely a great option. We've actually been having some fun on there. Consider it. And there's my plug for the MAS on YouTube. The best way to find it is Minnesota Astronomical Society YouTube. It comes up like #1 in your search.
Hey, Mark.
Yes.
Do you get data back from YouTube so we know how many people are actually watching?
Yes, we do. Yes. So like tonight's meeting, we had 70, 79, 78, 80, 77, something like that, have been on and off. So when I post, I usually come back in a week or so just to see how many people have viewed it. And usually within a week to 10 days, it's upwards of 25 to 30 people. I didn't check before today's meeting, but I would say, without even looking, I would say there's probably 40 people that viewed last month's meeting, which is kind of common. And if you go back to other months, sure, it goes up, which is fabulous. I mean, that's just a fabulous resource that we can put that up there.
Hey, Mark, Steve again. One thing also I want to point out for the new members that have joined within the last couple of months. Pre-COVID, we used to do member orientation meetings, and they were in person. But last year I recorded, maybe it was 2020. Anyway, a while back I recorded one that's up there on the channel too. So that helps. Some of the information is going to be outdated based on today's conversation, but it still provides a good overview of what's available in the club for benefits to all members. That's it.
Yep. Thanks, Steve. Anton, if you're on, you want to spend a couple on this Lunar Scope program, this fabulous Lunar Scope program.
Sure. Well, you pretty much covered it during the budget. Yes, we have our 16 telescopes now, of all varieties. We have Dobbs, we have refractors, we have Schmidt-Cassegrains, and we have a solar scope. Last year we loaned out 87 times. There are 3 telescopes out right now. This is not our busy season, clearly, nor has it been clear. So there are telescopes available if anybody wishes to brave the winter weather. And of course, as you were just showing on the screen, now we have all of these wonderful astronomy courses on DVD that are also available. So go online to Members Lunar Scope program and tell me what you'd like to use.
Excellent. Thank you. And yes, as a new member in 2010, I can't remember how many there were, but I want to think there's like 5 or 6 scopes in the Lunar Scope program. There might have been 8. Most of them were Dobbs, but there was a refractor and a Schmidt-Cassegrain. I actually used them both, and that's why I'm still here today. And that's why I have the collection of scopes that I have. Kind of sad. Don't tell my wife. So things that happen before next meeting. The most exciting part for me is new moon, March 2nd. I'm very excited about that. And then obviously the hybrid meeting on March 3rd. The rest of those things, you know, I have to say, it's not quite as interesting as some months. Just for everybody to know, there's no public events scheduled. First one's in March. CGO, anything goes down there. If you go down there, take a shovel, I think. But it is open, and if you're a key holder, you can even have a place to warm up. You know, nothing's really changed as far as our COVID protocols. That, you know, if you're in a building with someone, then you should wear a mask, and that's really it. And since we don't have any public star parties, there's nothing to worry about there. But, you know, if you are in a building with someone, you know, consider masking up to protect yourself from them, and you get it. So in February, later on this month, there's another BSIG event. It's online. It's going to be on Zoom. It's going to be recorded. Doug Neverman is going to speak about beginner imaging. I've seen that presentation several times. I'm sure he's modified it and made it even better. But Doug does a great job presenting. And other news, Metcalf Field now has AC power. There's some excitement for maybe about April or May when we can get out there again.
Hey, Mark, on that.
Go ahead,
point,
Shresh.
On that point, I think John Heyman needs to get a shout out. He did a lot of work with both Excel and electricians, and there's a lot of entanglements we had to go through. And I just want to shout out to John because he did a lot of work to get that done. It took almost a year from the time they pulled it out last year to when we got it back. And he was very good about keeping it going. So I want to shout that out.
Yes, absolutely. That's good call there, Shresh. I totally agree with you, John. I know that a ton of work. You know, both you know, getting the old stuff out of there, getting the mouse house out, and then obviously when we took that out, we lost power. And then he worked with Excel, and he worked with Bellwin, and he worked with our electricians and things like that we hired to do the work out there. Yes, John did a fabulous job. So, call for Gemini articles. I don't think this ever ends. This is you know, anything. I'm just going to go right to the last bullet and go, if you got anything having to do with astronomy, write yourself an article and then submit it to Father Brown, and it'll show up in the Gemini. That's all I'm going to say. Better know a constellation this month. I don't think there's any astronomical leaks because I think Jerry's banking them. He wants to deliver those first awards or those new awards at the next face-to-face. And his message to all of us is to get out there to observe. Next month, our speaker is Jessica Noviello. And she's going to talk about water in the solar system and beyond. And Ahmed probably knows more about her. I didn't go read her bio, but I'm excited to hear about this. You know, we know water's everywhere. There's water on Mercury, so I probably took something away from the thing. So tonight we were supposed to have Chuck Allen on, and he was going to give us a little talk on James Webb. But we learned on Tuesday that he had a forecast of heavy freezing rain. And I'd asked him to let me know this afternoon. And it sounds like he let Jerry know that he was not going to be able to make it tonight. So in his place, Jerry Jones is going to do a presentation. And Jerry, I'm sorry, you got 35 minutes.
Hi, everybody. Can you guys hear me all right?
Okay, I'm going to stop sharing now.
Yes, Jerry, we can hear you.
Oh, you guys did that very well.
Yes.
Done. Well done.
We planned it.
Yes, we can.
Yeah, nice job. Nice job. Okay, so, well, Mark had called me some of you guys are going to look at this and go, "Oh yeah, I've seen this one." Mark had called me. I think it was Tuesday, and had made comment about poor Chuck. And I did get an email from him earlier this afternoon because he's one of the Astronomical League coordinators, and he wrote this to me at 5:07. "Regrettably, I've lost power as of 3 p.m. and it's not back. We've had about half an inch of rain, but the wind may have been the real culprit. I'm terribly sorry to hear about this, and will do anything I can to make it up to you and your club. But I wanted to let you know I'll be in touch about a possible reschedule." So I think all of us were really excited and looking forward to that. But there was a chance that he wasn't going to be able to do that, and we knew that a couple of days ago. So Mark reached out to me and asked me if I had anything in my pocket. And so those of you who have been who were at LLCC this last fall, you might as well just sign off right now. It's okay. I'm going to take this point of view that you see on your screen, and I'm going to share just one little piece, because this has been a challenging meeting, and bravo to Mark and to the board and to everyone that came through, and these meetings are always rather challenging. So I don't want to belabor things, and I don't want to I think all of us need to get a beer at 9 o'clock or something like that. So what I want to share is about a half an hour of this concept, and then just one of the hinges. So the title is Pickering's Computers, the Hinges of History, How Two of the Most Important Astronomical Discoveries came about by women. And the whole concept of hinges of history is I think an important one in this situation, in that there really was something going on in astronomy in the 1800s, and what went on in astronomy in the 1900s was greatly affected by these women, by Pickering's computers, by these women who were hired from the 1880s to the 1920s. And so what I'm going to do, so that's the concept of a hinge of history, that these women really, a lot of things moved on them, and because of them, major things changed. So I'm going to scream through many of these slides. I didn't get a chance to readjust them, knowing that I only had a half an hour. But here's the state of science in the 1850s. You can see that really science wasn't much of anything until the 1800s, and even in the end of the 1800s. And in astronomy, pretty much the state of astronomy was really very infantile. There really wasn't a lot going on until towards the end of the 1800s, and particularly when it came to spectroscopy, which was chemistry, but it made a huge difference in astronomy. And of course, the state of the women, we can imagine what the state of women were. This is an interesting factoid. I find this really interesting. 193 women, according to Wikipedia, and 7 of those 100 were Pickering's computers. So this gives you an idea of how much of the aspect of the hinge that these women were, and just the whole setup and how it all worked. I'll let you read that yourself, and how clear that is. That was the concept of women in the late 1800s. We'll move on. Okay, so I'm not going to go through this, but suffice it to say there was a setup. So we're just going to kind of scream through this stuff. Here's the major guy. If it hadn't been for Edward Pickering and his mentality towards education, his mentality towards astronomy, he really was the person that moved things from visual through photographic to spectroscopic. He was the guy. That was really his goal, and his attitude and his mentality. And he had very progressive attitude towards women. And it's because of that he was in the right place at the right time. Really, this is a major key. Harvard Observatory, Harvard College wanted to be a mover and a shaker in the world of astronomy. And they made this decision around 1850, and it's pretty cool. Harvard owned a serious number of telescopes. Here's the big 15-inch, which was 1847, I believe. But it wasn't just that. If you take a look at this photograph, you can see probably no less than 10 telescopes on Observatory Hill at the time. And I'm going to, again, scream through these. Some of us kind of geek out about telescopes. Here are some photographs of telescopes that were owned specifically by Harvard Observatory. 16-inch doublet, another doublet. This was owned by Henry Draper. Another owned by Henry Draper. These were all given to Harvard once he passed away by his wife, Mary Draper, who was another huge portion of this. She was really the money that made spectroscopy work within the whole complex of the Harvard Observatory telescopes. 24-inch refractor. The Bruce doublet was one that was given to Harvard, and it was not only in Harvard, but it was also in Peru, and it was also in South Africa. And again, these were all telescopes that were owned by Harvard Observatory, Harvard College. And so this meant that there were lots of glass plates that were being sent to Harvard on a very, very regular basis. It's kind of a photograph of all of them. It's pretty cool. So that was the dilemma: too much data, too many telescopes, taking too many pictures. Development of photography came into here. Really, 1833 is when it started. 1839, John Draper, Henry Draper's father, took the first picture of a portrait of his sister. This is a pretty good portrait, actually, when you think about it. Some of the first photographs, 1847, the first photograph was taken of the moon, and he also took a photograph of Vega. Interesting, some people feel this is the first photograph of the moon. It was done by Henry Draper's dad, William Draper, 1840. Photography was only around 7 years by the time this guy took it. It's amazing. Spectroscopy comes into view. Single spectra. Pickering decided to put a prism on the objective lens, and this is where you wind up with every single star on a glass plate having a spectra that needed to be looked at by women. So we're going to kind of scoop through this stuff. So you have to forgive me. Okay, so we'll talk a little bit about parallaxes. I want to talk a little bit about Henrietta Swan Leavitt. Parallax is what was used for determining stellar distance in the 1800s. In fact, it was used by the ancient Greeks for a lot of different purposes: Earth's circumference, distance to the sun and the moon. 1769, parallax was used in viewing the transit of Venus to determine the astronomical unit. 1838 Bessel was the first astronomer to determine distance to a star, 61 Cygni, the double star. Parallax is limited by equipment, and the simplest way to imagine what parallax is for us is if you take your thumb and put it in front of your face, right next to your nose, and blink your left and right eye back and forth, and you see how much your thumb moves against the background of whatever you're looking at. And if you put your thumb at your arm's length and do the exact same thing, look at your thumb and then blink your eye, or left and right eye, and you'll notice that farther away, your thumb doesn't move that much against the background of what you're looking at. So farther away, less of a parallax, which is called proper motion. That's the motion of the object against the background. And if it's closer, it has a larger. And so this is how it works in a star. You can see here, these are the, there's my cursor. You can see here are the 4 places where the Earth can be. Here's the sun, this is the Earth. And so parallax are taken, parallax observations are taken, and if the star is closer, it creates a larger motion against the background of stars, and if it's farther away, it creates a smaller motion. So this is how in the 1800s up to 1900, this was how distance to stars, distance to anything farther away, was determined. This was it. Now, the trick of it is that if you take a look here, parallax only got us about 100 light years away. Beyond that, there was nothing we could do. We just simply couldn't see them because parallax is limited by equipment. Now, today we have satellites, Parker satellite and Gaia satellite, that uses all sorts of so much better equipment and technology, and we can see a little farther out than that. But this was the state of astronomy as far as determining the distance at that time. So here they are. Here's a picture of some of the Harvard computers. They were also called Pickering's harem. You can see that Pickering is back there, and this was 1913. The women were there. There were around 80 were hired between the years, and about 20 at a time. And from 1885 to 1927. And what they were hired to do, we'll just move on to a couple pictures of just kind of feast your eyes on some of these great, wonderful pictures of these lovely ladies. They were hired to compute actual positions and brightness of individual stars by applying mathematical formulae to the nightly notations made by male observers. Women, except Annie Jump Cannon, women were not allowed to be at night at the telescope because that wasn't appropriate for a lady. They were given glass plates. They were asked to discover new stars. They counted the dots. They cataloged all of them according to sky coordinates. They determined the magnitude of variable stars, which are stars that change in brightness, which meant they had to compare them to past glass plates. And they took plates like this and they turned it into data, which is just amazing. And the way they did it, as you can tell, here's a photograph of Wilhelmina Fleming, which unfortunately won't have time to talk about. Here's good old Henry Pickering over here. And you can see that the ladies are working 2 by 2. And the way that they did it is that one person was looking at a glass plate and with a magnifying glass and making notations of what she was seeing, and someone else is writing them down. So they made a point of working in twos. And if you take a look at this photograph, I'm hoping you can see my cursor here. Let me know if you can't, then maybe I can find some other way to do it. These are all glass plates. These are all glass plates. And when you think about it, I mean, this was astronomical needlework. These women have so much focus and concentration. And in fact, there's a story about Edward Pickering, where Harvard was really wanting to develop astronomy as a field. So they were even in the late 1800s, they had classes, and they were doing undergrad and some grad work to build astronomers, to teach astronomers. And so at this time, Pickering, as he started doing this, Pickering wanted to get his male PhD candidates into doing this work, and they were horrible at it. They had no concept of the attention and detail that was necessary to do this work. And so the story goes that Pickering got angry one day and said, "My Scotch maid can do better than you." He was speaking of Wilhelmina Fleming, who was his maid at the time, and wound up indeed being able to do a much better job than any of them. And that really was how things got started. And they found that women's ability, attention to detail, really worked very well within this concept of doing all this crazy stuff. And here were some of their tools. Here's an example of, whoops, my apologies. Here's an example of the tray that they would put the glass plate on. And this is what was called, I think it was Leavitt who gave it this title, a fly spanker. And you can see along here are dots that designate certain particular magnitudes. So they would place this fly spanker on top of a glass plate, and that's how they would determine the magnitudes of particular stars. So Wilhelmina Fleming, which unfortunately we won't get much of a chance to talk about, she really was a mover and a shaker, one of the first movers and a shaker. That's her up on the upper left. Annie Jump Cannon is on the upper right, and it's Henrietta Fleming at the end. Wilhelmina, just really briefly, she worked on the spectra of stars. In 1898, she became the first woman to hold a title at Harvard. She was the curator of astronomical photographs. And since I'm sharing a little bit about her, this was the photograph that she discovered, the Horsehead Nebula. And I'm not sure if you can see it. Here, of course, is the Orion Nebula. Here are the 3 stars of the belt. And here is the horse head right there. How crazy is that? It's pretty cool. And these are some of her honors. Annie Jump Ken was another one who worked on stellar classifications. And because of her and Wilhelmina Fleming, we have this. And that's a very long story, but this is perhaps the most important chart in astronomy today because it talks all about stellar evolution. And she was the one who coined the phrase, "Oh, be a fine girl, kiss me," which was the mnemonic for remembering the series of stars that were categorized finally, not by anything else, not by hydrogen lines of the spectrum, but by color and temperature. So that really is what she gave us. And she had quite a number of honors. You can see that right now in 1914, admitted to the Royal Astronomy Society. She was the first female to get an Oxford doctorate, which is pretty darn cool. She was, and actually the one that I find most comical, of course, this is today's world. In 2014, she got her own Google Doodle, and we all know about Google Doodles, and there's hers, which is kind of cool. Okay, so we're going to slow down a little bit, and we're going to talk about Henrietta Swan Leavitt. Now, Henrietta, in my opinion, was the queen. She was an interesting woman. Her father was a congregational minister, which meant that he and her family did a lot of traveling. They started in Cleveland, they went to Cambridge, and they eventually wound in Beloit, Wisconsin. She came by many of her mathematical ideas, her mathematical abilities. Honestly, she had an uncle who was an engineer who invented what was called the Leavitt pumping station in the Boston Water Works. She attended Oberlin when she was at Cleveland, and when they were in Cambridge, she attended Harvard. Of course, because she was a woman, she couldn't attend Harvard. She had to attend Radcliffe. She had a very broad study, and it wasn't until her fourth year that she began to study astronomy. And she loved astronomy so much, and it had such an effect upon her that she began volunteering at Harvard in 1892. 1893. She was partially deaf, although we don't know how it happened. We know that it was not congenital. But she was a very, very private person. Unlike Annie Jump Cannon, who wrote tons of letters, was a very personable individual, even though she was also partly deaf. Henrietta, we don't really know a great deal about her. We do know that she had all sorts of stomach issues all of her life, and she did eventually die of stomach cancer. She did an enormous amount of work for Pickering's pet project, which was the North Polar sequence. He really had a bee in his bonnet to create a systematic catalog of all the stars around Polaris, around the North Pole, and that really became her job. Whether it was something she really wanted to do, we don't know, but we know that was her major work. But she is most known today as the developer or the discoverer of what we now know as Leavitt's law. So Leavitt's law has to do with standard candles. Now, we talked about parallax, standard candles for determining distance in large distances. And so this is where this comes in. Now, from antiquity, there were 5 variable stars that had been known: Mira, P Cygni, Chi Cygni, R Hydrae, and Agel. But that was it for centuries. There was the only ones that had been noticed to change. But things changed in 1784 when John Goodrich, another very interesting British young man, discovered what he thought was another variable star, and he found it in Cepheus, and it was the star that was by the Bayer designation of Delta, and so any star that matched the basic concept of how Delta Cepheid varied in as far as its periodicity and its amount of luminosity wound up being called a Cepheid. And Cepheids were discovered that they were they're really quite common, and they were very bright. But the reason why they weren't seen up to 1784 is their pulsations were between 1 and 100 days. And so they weren't all that obvious unless you were really looking for them. If you were looking for them, you could find them. But of course, no one really knew they were there until after 1784. But this was the issue, is that Cepheids had a relationship between the period of their pulsation and their luminosity. And this was the whole part of her paper in 1908. In 1908, she published a paper that was based on her observations of 1,777 variables in the Magellanic Clouds, 969 in the small Magellanic and 808 in the large. And in this paper, she makes this understatement, quote, "It is worthy to notice that the brighter variables have the longer periods." And when the astronomical community just saw that and they read the paper, this is what rocked the astronomy world. And this is how it works. So light, energy, works with what's called the inverse square law. And you can see here is that as the distance doubles, the area upon which that energy falls is by the square root. So that's called the inverse square law. So if we take two stars, and we're going to assume this is brighter because it's bigger, we know really nothing about these stars. We don't know anything. All we know is that this star is brighter. Now, this could be this could be brighter but farther away, or this could be dimmer and closer. We just have no idea. But then using her comment about saying it's worthy to notice that the brighter variables have longer periods, we can go ahead and then if they're Cepheids, we can figure out what their period is. And so let's just say this one has a period of 5 days, and let's say the period of this one is 5 days. And then we can make an assumption of which one is closer, because the luminosity is the same, because they have the same period. And that's the key, because the period is the same, the luminosity is the same. And then we can if the period and luminosity are the same, the one that's brighter is obviously closer. So here's the math that has to do with it. You can take a look at it yourself. But they were around 1908, a couple of years after this, they were able to determine the parallax to Cepheids within that 100 years range. And that was then they were able to match that to Cepheids that were farther away than the 100 years. And so they were able to move from 100 light years to 20 million light years almost instantaneously. And what they figured out was that a Cepheid that has a day period, that the variation is within a day, is about 300 solar luminosities. 10-day period, 3,000, 100-day period, 30. You can tell these things are really, really bright. And so now we're back into that concept of standard candle. And now we see that the Cepheid variables become the standard candle all the way out past the Andromeda Galaxy. And in fact, this is what Hubble used when he determined that the Andromeda Galaxy was an island universe in and of itself. The difference I want to make here is that this was a discovery. She discovered this. This wasn't an evolution. This was something that she was in the right place at the right time, figured it out, and she made this discovery. And she did it by looking at the variables within the Magellanic Clouds. And so she made the assumption that all of these stars were the same distance. That allowed her then to look at, in fact, she took care of one variable that allowed her to look at the other variables, which were the issue of brightness and periodicity. And you can see right there how that all worked out. Now that's her chart. And she did it by looking at plates just like this one, which is really amazing. So Henrietta Leavitt is going to be remembered on top of discovering more than 2,400 variables, she in 1913, she set a standard of photographic measurement. Now, what that meant is that she figured out how to look at these plates the appropriate way, and she had an amazing way of looking at them. She figured out if she stacked a certain number of plates in a certain particular way, and she had the observatories make certain types of photographs, she could compare them in a faster way, and that method was accepted by the International Committee of Photographic Magnitudes. Her North Polar sequence, it is an amazing piece of work and could easily have been her PhD multiple times over. One of the sad things about her life was that she passed away in obscurity. And really, no one outside of the astronomical community, outside of Cambridge, knew that she had passed away. In 1926, a Swedish astronomer named Gösta Mittler-Leffler came across her work, her specific work, and realized, this stuff is worth a Nobel Prize. He wrote a letter to the Harvard Observatory. Pickering by this time had passed away. Harlow Shapley was in charge of the observatory, and so asked Shapley, hey, I really want to nominate this woman for a Nobel Prize. Shapley had to tell him, well, she had passed away 4 years ago. And as we all know, that they do not award Nobel Prizes posthumously. What's kind of weird is that Shapley felt that Leffler should nominate him, since he was the one who was using her discovery. Luckily, that never happened, which is okay. She has had some honors. There's a great play. Some of you have probably seen the great play, Silent Sky. There's a couple of books. Miss Leavitt Stars is one. There's another one about her, and not only about her, called Glass Universe. She has an asteroid named after her. She's got a crater on the far side of the moon. But the biggest difference, now there were a lot of Pickering's computers, a lot of these women who really did get a fair amount of accolades. Henrietta Leavitt was given quite a number of accolades during her lifetime. She was involved in the Chicago Exposition. I'm going to say that was 1898. Even though they were not paid terribly well, they were paid about $500 a year, about 25 cents an hour. That was pretty good money for a woman at that time. Remember, as Edward Clarke said, they couldn't work on two different things at the same time, or else their reproductive organs wouldn't work right. Sigh. So there were actually a number of the Harvard computers who did get some. Annie Jump Cannon got quite a lot of notoriety. But most of them did not. Most of them just worked like crazy, putting together Pickering's vision of making Harvard Observatory a world-class repository of data. And that really became very true. In fact, today, Harvard owns over 500,000 of these glass plates, photographic plates, from 1880 something to 1960 something, and they are in the process of being digitized, which is wonderful. All of not only just the plates, but also all of the data, all of the log sheets. But Henrietta Leavitt, I think, in my opinion, is yet to be really thoroughly acknowledged, even though she did get her name on the Sky and Telescope a couple of months. I think it was December. But the difference is that so much of what the women did was evolution. So much of what Annie Jump Cannon did, by the way, was evolution. But of course, if it wasn't for her work, Hertzsprung and Russell would not have put together the HR diagram. But it was a process of evolution. With Leavitt, it was different. It was discovery. It was totally discovery. And, it can be said that discovery obviously would have been made at some point in time, but it's hard to know exactly when that would have happened, how that would have happened. So I'm going to conclude, because some of this stuff we didn't really get much of a chance to talk about, but these are the hinges. These are the pieces of the hinge. Henry Draper was so inspired by his father in photography. And if he hadn't, his wife would not have been so committed to his work. He would not have given the money to Harvard. And Pickering might not have done all of these magnificent things that he did. And what if these amazing women had not existed at the time when they existed? We don't know. It can be argued that if Einstein hadn't come up with the theories of relativity, someone would have. And that's a logical and reasonable argument. At some point in time, it would have been figured out. Would someone have figured out Leavitt's law? Yes, probably eventually that would have happened. But the fact of it is that it was discovered by a quiet, unassuming, very private person who, in a few words, rocked the astronomy society and continues to rock the astronomy society. If it hadn't been, if it wasn't for Leavitt's law, we simply wouldn't know how far things are. Any questions? You got 4 minutes.
I kind of noticed I didn't see a single light bulb anywhere
Light bulb.
for lighting the rooms overhead or the equipment as such. All done by candle or kerosene.
Well,
the
yes.
actually the glass plate viewer they used near a window, and the
Correct.
light reflected from the mirror off of from the window off a mirror to backlight the glass plates.
Yeah, but still, as I said, no real electricity for most of them to do that work.
That's true.
So
Yep.
that's says a bit there, and you consider some of the other aspects of the facilities of the time. So what these ladies did was, in all respects, miraculous by today's standards.
Good
Yeah.
word. Good word.
I've got a couple things to say. This is Dave Faulkner. One is, if you want to know more about some of the characters that Jerry talked about, it's in my book, Stories of Astronomers and Their Stars. And then the other thing is that I want to plug also, Jerry mentioned it, but the whole story about the Harvard computers is in a book called The Glass Universe by David Sobel. It's an excellent book, and she did a really great job of researching all the work and all of these gals and the stuff that was done there at Harvard during this time. So that's it.
Anything
Anyone
else?
else? Hey, Jerry. Get out there and observe. Thank you, Jerry. Jerry, thank you. I'm sorry. I tried to get you an hour, but you know how business
No
is.
problem. There are more important things to be done. Happy to be of service.
Yeah, thank you for filling in. I'm sure
Oh,
Ahmed will get Chuck rescheduled.
Yes, and he wants to very much.
Yes.
Wait, how do I stop? How do I stop?
Just click the share and take it off. That's all you need.
I'm trying to find it. Oh, there, it's down there. Aha.
Share screen, then should do it all. There you go.
So that's all we have for this month. See you next month. I hope we see some of you face to face. If not, we're going to stream it and we're going to record it and have a great month. Thank you.